automated redaction of names in adverse event reports using transformer-based neural networks, in the BMC Journal of Medical Informatics and Decision Making. In the UK, there's something called the yellow card scheme. When someone has an adverse reaction to a drug or vaccine, a report gets filed with this program. Public health officials aggregate these reports and run signal detection analysis on them to determine if certain drugs need updated warning labels or to be pulled from the market. In order to process the individual reports, the names of the patients need to be stripped out of the text in the submissions. Today's paper is focusing on just that process, the act of taking a bunch of raw text and removing the names from it. Sounds easy, right? Well, don't be so sure. Let's walk through it. Imagine you're writing a function called redact names. It takes one parameter, a string. Your function needs to accept the string, replace any names with a series of asterisks, and return the string. But here's the thing. It needs to handle full names, partial names, or initials. And remember, people's names may have any kind of capitalization or no capitalization at all. They may have periods, hyphens, or other characters. They may be one word or one letter or a series of words and letters. A name could be 2 words, 3 words, 4 words, or more. They may be spelled correctly or they may have typos. There may be standalone sentences that contain nothing but a name, and in other cases there may not be any names in the passage at all. Think that's not complicated enough? It gets worse. Medical writing is often chock full of what are called medical eponyms. Diseases, conditions, surgical techniques, and more are often named after the person who discovered or popularized the knowledge of them. For example, Parkinson's, Alzheimer's, Hodgkin's lymphoma, Down syndrome, or Crohn's. There are hundreds of medical eponyms, and your function shouldn't redact any of them, because they are not human names when used in this context. They are medical information. Can you think of any standalone function you could write, any procedural algorithm, or any regex expression you could create that would do this job? I can't think of one, and neither could these authors. So when they were faced with this problem, they decided that they needed to fine-tune a pre-trained LLM. This paper is all about how they chose the model, the fine-tuning process they went through, and the results they obtained. If you're already subscribed to our email newsletter, you'll be getting this episode in text and audio form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.